Good day, learners. In this video, we're going to discuss the lesson Triangle Inequality Theorems. Under this lesson, we have two subtopics. The first one is determining whether three given sides can form a triangle. The second one is finding the range of possible values of the third side of a triangle given two of its sides. The key idea that we're going to apply is the Triangle Inequality Theorem. According to the theorem, it states that in any triangle, the total length of any two sides is always greater than the length of the remaining side. Let's talk about first the subtopic number one, determining whether three given sides can form a triangle. Let's have this example. You have three strings of lengths 13, 15, and 22 centimeters. Can this form a triangle? Let's have the illustration. Let's see the first one or the first string has a length of 13 centimeters. The second string has a length of 15 centimeters and the last string has a length of 22 centimeters. By applying the triangle inequality theorem, where we're going to obtain the total length of any two sides and check whether they are always greater than the length of the remaining side, we're going to have our solution. And it will go just like this. Okay, so on the first column, we're going to put all the combination of the sides and we're going to add them all, of course, to by per to length of the string. On the third column, we're going to put the sides that are not included on the addition of the lengths. And at the second column, we're going to put either less than or equal symbol or less than equal to. Of course, I didn't put the equal sign right there, but it is also included. We're going to either put less than and greater than. Of course, let's add equal symbols for our numbers. Okay, let's start first with the first combination. So the first row, it states that if we combine the length of the first and second string, which are 13 and 15, we're going to obtain 28. From the given lengths of strings, we did not use 22, so that will be put at the third side. Now we're going to compare the sum, which is 28 and 22. Obviously, the sum of the two sides is far greater than the third side. Next, let's talk about the second row. In this case, we have the combination of the lengths of the first and third string. And the third side will be presented by the second length of the string, which is 15 centimeters. 13 plus 22 is equal to 35. And obviously, 35 is greater than 15. So we put the greater than symbol at the middle part of our, at the second column of our table. And then for the third row, the last combination that we have is 15 plus 22. We use here the second and third lengths of our strings, and we put the length of the first string at the third side. And now, if we're going to obtain the sum between the second and third string, we're going to get 37. And that is also obviously greater than the third side, which is 13. By looking at all the combination of our lengths, we could see that all sums are greater than the length of the remaining sides. So therefore, we could conclude that since the sum of any two sides is greater than the third side, the strings of lengths 13, 15, and 22 centimeters can form a triangle. Now, if you're going to ask me, sir, what if, excuse me, I obtained a sum in any of those combination, a sum of numbers or lengths that is less than the third side or equal. So right there, we could not say that we can form a triangle because it does not correspond to the statement of the triangle inequality theorem that All the combinations of the sums of the lengths of the first two strings must always be greater than the third side. Okay, as simple as that. Now let's proceed to the subtopic number two. This time, we are going to find the range of possible values of the third side of a triangle given two of its sides. We are talking about range, not only a number, so therefore that range includes numbers, okay, or lengths that are that corresponds to the given theorem. Okay, now let's proceed to this example. Two sides of the triangle have lengths 8 and 29 units. What is the range of the possible values of the third side? Now, let's have the illustration. The first thing that we need to do is to, for us to be able to use the given, excuse me, okay, let me continue. So for us to be able to use the theorem of the triangle inequality theorem. So we're going to represent our data first with our variables, okay? The first thing that we need to do is to represent A and B, no? The sides or the lengths of the sides that we have. So let A and B be the two sides of the triangle. And let's follow the condition that A must always be greater than or equal to B. Obviously, based on our given, A will be equal to 29 units. That is greater than the second side with only 8 units of length. So that will become our B. Okay? And of course, we don't have the length for our left side, so we're going to use C for it. Okay? Now, for our main solution, the first thing that we need to do, of course, for us to be able to present a range of our values now for our letter C is to apply, of course, the inequality of the theorem or the triangle inequality theorem by using variables. It is stated that the two sides, if we're going to add them, it must always be greater than the third side. And based on our given, the two sides that we have are A and B. So A plus B is greater than C. If we're going to substitute the given, we're going to have 29 plus 8 greater than C. Okay, so this time we have the inequality or, of course, the condition, not a condition, but yes, it is a condition that if we're going to obtain the numbers or the sum between 29 and 8, it will be greater than C. Okay, now, if C is less than the sum of 29 and 8, we could say that there are numbers not under that range that are less than the sum between 29 and 8. What about the numbers that are less than C? Because in this case, we have numbers that are for greater than C. So to proceed with that, we're going to this inequality. So this time we're going to get the difference between A and B, and this difference are all less than C. So by substitution, we're going to obtain 29 minus 8, which is less than C. To put it simply, we're going to put C. We're going to arrange it in a way that we could easily understand our given inequality and condition. C is our third side. That is the missing side. And we are talking about the range of values that we could insert on that variable. So we're going to use the first condition. It is stated that C is less than the sum between 29 and 8. But C is also greater than the difference between 29 and 8. To simplify it further, we're going to get the difference and sum of those numbers. We're going to obtain 21 and 37. To make it short, the C is greater than 21 but less than 37. So the lengths that we could put at our missing side C could be 22, 23, 24, up to 36. All those lengths could satisfy the given statement of our theorem. Okay, so therefore we could simply have this conclusion. Therefore, the range of values of the third side of the triangle above Is C greater than 21 but less than 37? And as an additional idea, we could also put our answer in its interval notation where we're going to enclose both our boundaries 21 and 37 by a parenthesis. A parenthesis means if we're going to go back to our lesson about number line, it states that the numbers inside right here are not included on our range or it presents an open circle. Okay, so to make it short once again, to answer our question, what is the range of the possible values of the third side? Simply C or the length for our C or missing side enclosed by x is greater than 21 but less than 37. And that is all. Thank you for listening.